Hi everyone, welcome back to Data Science in Your Pocket. And OpenAI has recently released a new research paper mentioning why language models hallucinate. So, it's a very interesting paper giving us the reason of language model hallucination and what should be done to improve on this. So, in this short video, I would be explaining you what the paper is all about and what solution and conclusion the team has given. So, let's get started. So, starting off, first of all, let's understand what are hallucinations in LLMs. When a model doesn't know the information, you ask it a question, it doesn't know it. It doesn't say, I don't know, usually, but it starts off with a lie. For example, incorrect birthdays, wrong thesis titles, fabricated facts are quite common. Hallucinations are confident, plausible, but false statements produced by language models. We all know this. Research paper overview. Why language models hallucinate? This is the name of the paper. Hallucinations are not bug but inherent to how models are trained and evaluated. The way we are training and evaluating, that is why hallucinations are present. So these are the certain terms that we would be explaining in this short video. Hallucinations are statistical inevitabilities of pre-training. Evaluation methods perpetuate the problem. Theoretical framework, is it valid? Classification problem, and solutions require changing evaluation benchmark. That is very, very important. So, first of all, let's talk about the first pointer why LLMs hallucinate, that is the training. Even with the perfect data, LLMs will hallucinate. Why? Because an LLM which is poor with classification would surely be hallucinating. So, they have called up a framework called as Is It Valid? Where an LLM is asked to say give a sentence, select whether it is valid or error statement. Now they have given an equation. If the generative error rate is greater than or equal to 2 into is it valid misclassification rate, then in that case the LLM will surely hallucinate. Right. They've also given a singleton rate example. What they say is that eventually if a very rare fact is appearing once in the training data set, like for example xyz has his birthday on 22nd of October, it's rare, it's a fact which is coming very rarely. In that case the LLM will hallucinate on that particular fact. Model has no strong pattern to generalize from. Right, this is called a singleton rate example. The example is coming just once. This particular framework they are calling is it valid classification problem. Higher the misclassification rate, higher the hallucination rate. It's not about the model being lazy, it's all about stats as they mention in the paper. The second thing is not just the training part, even the testing or the evaluation part, the pre-training part, RLHF you might have heard of, makes hallucination stuck. Because you would be asking this, okay, if we are doing a supervised fine tuning or whatever, and then we are doing an RLHF, it should have improved. No, it won't. Why? Because the rewarding system is not great. Epidemic of penalizing uncertainty. Models are punished for saying I don't know, right? The reward system is 0 1. Either you say incorrect or correct. There is no reward when you say I am confused. Right. So all the benchmarks also like MMLU, GPQA, SW bench are all 0 1. You give a correct answer, you get an answer. If you go incorrect, you get an incorrect the 0. Hence the model rather than saying I don't know tries to attempt the question, right? Because the higher chances that it would be able to get a reward. Hence the rewarding system, entire rewarding system is not considering also the I don't know problem, right? It is quite analogous to student taking an exam. If you get points just for the right answer but 0 points for blanks, eventually you won't want to leave anything blank, right? You would want to answer something to get the reward. The problem with current benchmarks, as I already mentioned, +1 or 0. There is nothing in between. So the new system that should come in should be something like this. As you can see, the current system is +1 for correct, wrong is equals to 0, I don't know is also equal to 0. While the proposed system should be correct is +1, wrong is -1, and I don't know should be 0. Consequences of binary scoring is problematic. Guessing is rewarded, right? For example, for 10 questions, even if you get 2 right answers by guessing, you are increasing your numbers. Uncertainty is penalized, vicious circle. Leaderboard ranking reinforce guessing behavior. So models are encouraged to guess rather than saying I don't know. What the author suggests, as they said, fixing the mainstream benchmarks is very important. Change scoring system to reward honesty, give credit for uncertainty, and penalize only wrong answers. Impact of high stake applications. So why is this important? Because hallucinations are affecting a lot of applications. Also, the people are not able to trust AI because of this. Medicine, law, finance are the biggest domains which take the maximum hit with hallucinations. So the path forward, hallucinations are statistical inevitabilities of pre-training. Evaluation methods are perpetuating the problem, and it's not a technical issue, it's a socio-technical challenge. Within our society also, if you notice, people are not rewarded for saying I don't know, right? They are rewarded the same as saying wrong. This is how what has gone into the benchmarks also, which shall be changed. What are the final thoughts? Training makes hallucination unavoidable, evaluation makes them persistent, and fix requires better questions and different grading also. So with this, it's a wrap. It's a very interesting paper. Give it a try and let me know in comments how you feel about it. Thank you so much.